Hello Tech World, this is TechThoughts, and welcome to this special TechThoughts video series focused on learning PowerShell. This is an operationally designed series that aims to get you spun up in using PowerShell quickly. This is episode 8 in the series, handling PowerShell errors and exceptions. As always, if you prefer written documentation, the corresponding article for this topic can be found on the techthoughts.info blog, which I've linked in the description below. Let's go ahead and get started. Up to this point in the Learn PowerShell series, all the code has just worked. But as your code gets out into the real world, it's likely going to encounter the unexpected, and you're going to need to be able to handle PowerShell errors and exceptions. Did you know that PowerShell actually has two pipelines? So if we run, for example, git process, that goes out to the success pipeline or the success stream, which we see out here in the console. But if we provide PowerShell something it's not capable of doing, like dividing 1 by 0, that instead goes out to the error pipeline or the error stream. In some cases, this might be desirable, but in most cases, you're going to want to be able to handle these types of exceptions. So let's learn a couple of things that we need to know about PowerShell errors and exceptions to be able to handle these types of situations. The first thing you need to know about PowerShell errors and exceptions is that the vast majority of them are non-terminating. So what do I mean by that? So if you've been using computers for any length of time, you've likely encountered a program or an application that crashed because something in the code had a problem and it terminated. But the vast majority of PowerShell errors don't do that. They don't crash PowerShell. They're non-terminating. So let's look at an example and determine what does that actually mean. So here, notice that I've put this semicolon. And what that means is that both of these commands are going to be run when I execute this line. So the first thing PowerShell is going to try to do is divide 1 by 0, which we know is going to create an exception. And then it's going to try to write host, hello, will I run after this error? So I'm going to put my cursor right here, click F8, and notice that we do get the error here in the error pipeline, but it also went ahead and ran, hello, will I run after this error? That's because when it encountered this exception, it didn't terminate. It went ahead and threw it out to the error pipeline and continued processing the code. This is a very important thing to know about PowerShell, as the vast majority of errors behave this way in a non-terminating fashion. So why does PowerShell operate this way? Well, it has to do with its operational nature. Remember that PowerShell's job is to make your life easier and to allow you to do some really quick, awesome automation type things. So let's take a look at something where you might be evaluating some files. So here I have an array of collection where I've given it a couple of different file paths. So a couple of CSVs and a text file. And one of these doesn't actually exist on my file system. Now we have a for each loop here where we're going to be looping through every single one of those file paths and getting some information about those files. When you look at this, what is your expectation of what PowerShell will do? Do you want it to error on this particular line right here where that file doesn't exist and stop all action? Or would you expect it to evaluate every file that you give it, log the error, and then continue on? And that's exactly what it does. So we'll go ahead and load this into memory. We'll go ahead and clear this console with CLS, which is clear. You can also type in clear. They both accomplish the same thing. I'm going to go ahead and load this in, click F8, and notice what is going on here. The first thing that happened is it found the first file, new CSV, and we got some information from that. It went ahead and errored on the second nope.txt file and put that out to the error pipeline, and then found the second file, new CSV2. It's the same thing if you were to run git process. Your expectation from PowerShell, if it fails to evaluate one of those processes, is not to immediately terminate. You would want the information from the rest of the processes that it is available to evaluate. And if it encounters an error, it can go ahead and log that out to the error stream. In a lot of cases, this non-terminating behavior may not be desirable. If you hit an exception like 1 divided by 0, you may want to actually stop and address that or perform various different actions. And in order to do that, you're going to have to force PowerShell to terminate on the error. And I'm going to walk you through a couple different ways that you can accomplish that. So let me load up some code real quick where we'll try two different methodologies for terminating errors. So first I'm going to demonstrate again native PowerShell behavior. So here, without the error action parameter provided, we're going to run get item, again evaluating that file that doesn't actually exist, and immediately after saying hello, will I run after this error? So I'll go ahead and run this with F8, and we get the error where we can't actually evaluate the file out to the output stream. And then I see hello, will I run after this error? So again, that non-terminating behavior. The difference on this line here with ErrorAction is that notice for the commandlet get item, I've provided it the ErrorAction parameter. This is a default parameter that's available for all commandlets. So this is telling PowerShell, when you run this commandlet, I want you to change your non-terminating behavior to operate differently. I want you instead to terminate. I want the error action, if you encounter an error, to be stop. So if I load this line, we would expect with this parameter that the write host would not execute this time after this particular line is run. So we're going to go ahead and load that with F8. And notice that it does go ahead and error out to the error stream, and we do not see the write host afterwards. We have caused this first commandlet here to terminate. So why would you want to change PowerShell's non-terminating default behavior? Well, that's where we introduce try-catch. Because with try-catch, you can do additional things if you actually trap those errors that are encountered inside of your code. So let's again evaluate the non-terminating behavior and kind of get a sense for this. Try-catch is a pretty common methodology in most programming languages where we're going to try to run a line. And depending on the success of that, if it errors, we would expect it to go to the catch and throw an error or perform some action inside of the catch. So again, this is a best attempt for the code to accomplish something, some logic that you've put here. But if it can't perform it for whatever reason, it's going to fall back to the catch and perform whatever you put inside the catch. So let's go ahead and demonstrate this real quickly. I'm going to load the entire try catch. And again, in here, we're doing the same thing we did before, dividing by 0 first, and then seeing if it will write out to console. I'm going to go ahead and clear this with CLS so we get a nice fresh console. And I'm going to load this into memory and click F8. Okay, so let's evaluate this behavior. It attempted to divide by 0 as we see in the output stream, but notice that we do not see the write host. This try catch changed the behavior of the non-terminating nature of PowerShell. Because of this 1 divided by 0 being executed here, and because it encountered an error, instead of going to the write host here, it went from the 1 divided by 0 down into the catch, and I had it go ahead and throw right there. Notice that if I replace this throw with a write host, and I can say, you are now in the catch, clear our console window, and load this inside of memory, click F8, that we see that it tries to divide 1 by 0 and immediately goes down to you are now in the catch. Notice that you don't see the error now because instead of throwing the error out to the output stream, we didn't actually output the error here. We did write host instead. So again, that catch is going to perform whatever functionality that you put inside of that catch. So if you do want to see the error, you can do things like write error. And again, this is a pipeline, so you can use $_ and it will funnel whatever is inside of that pipeline out to the console. And because we have an error in the error pipeline, it will funnel that out with write error. So I'm going to load try catch again, and this time we'll perform both functions. We'll try to divide by 0. We immediately go down into the catch. We write the error out to the console, which we see here now. And we also write host, you are now in the catch. So again, you can perform whatever functionality you desire inside of that catch, which really empowers you to handle errors in various ways. Okay, so a couple of things around try-catch that are unique to PowerShell is that while this was a logic function or kind of a syntax function or an algorithmic error, those will immediately terminate in a try-catch and go down into the catch as we just demonstrated. But again, commandlets are not like that. Remember, the error action for commandlets is always going to be continue. So you're not seeing it here necessarily, but every time you run a commandlet, the error action parameter is specified for you, and it's set to continue, also known as non-terminating. So when you put a commandlet here, it is set to error action continue, and it will not obey the try catch. It will not actually terminate and force down into the catch. So let me demonstrate this for you. We'll try to get that file that we know that doesn't exist, and then we'll see if it runs right host afterwards, or will it go down into the catch. So we'll go ahead and clear that right quick and load try catch into the terminal window. And let's evaluate what happened. It went ahead and tried to get that file information. It errored because it couldn't find the file, and it did go to the right host that says, hello, will I run after an error? And it did not go down into the catch because the error action is continue. So we did not terminate here. Instead, we continued and we never made it into the catch. So how do you handle this when you're trying to run commandlets? Well, in this example, it's pretty simple. You specify the error action. You have to tell PowerShell not to acknowledge its default behavior. Again, if that's a little confusing, PowerShell is able to recognize in a try-catch syntax errors, spelling mistakes, things of that nature, or basic algorithmic errors that it can't accomplish. And those in a try-catch situation will acknowledge and go down into the catch. Whereas before, outside of the catch, we demonstrated that it defaulted back to non-terminating. But when we put these types of errors in a try-catch, they will go down into the catch. But again, these commandlets, they do have that non-terminating behavior and won't acknowledge it unless you override it with the ErrorAction stop. So here again, we're trying to get that file. We're not confident that we're going to be able to get it. So we specified ErrorAction stop, and we're going to perform this right host. You are now on the catch if it can't be found. So I'm going to go ahead and F8 that, and notice that it goes ahead and runs and says you are now on the catch. So this is the proper way to trap the various actions that you're trying to take inside your PowerShell code by performing that ErrorAction stop if it's a commandlet, and then forcing it down to the catch and performing whatever action that you deem necessary there. Let's take another look at an example inside of a loop to show you the kind of the behavior that happens with PowerShell as it engages this non-terminating behavior, even in a try-catch. So again, here I have an array, and I have two processes, not a process and Notepad. We'll go ahead and launch a Notepad real quick to have that process open. Go ahead and minimize that. And so this is going to loop through each of those processes. It's going to try to get process information about those two processes that I've specified here. Obviously, it's going to error on this one, as that not a process does not actually exist. And the behavior that we would be expecting here is this is going to be non-terminating, because we have not specified error action. So we should not go down into the catch. So let's load this up inside of memory and loop through those two processes and see what the behavior is. I'll clear the console real fast and get this loaded into memory. Click F8. So notice that based on our code that we provided it right here, that it did loop both times. The first time it looped and tried to find not a process. And of course it could not find it. And we see that put out to the error pipeline. And then it found the second process, Notepad, and provided that information back to the success pipeline. So essentially in this particular situation, in this for loop, this try catch is useless. It's not actually accomplishing anything without the error action being provided. So if I provided the error action stop, and we run this again, we'll see what the behavior of the loop operates like. So I'll go ahead and clear this, and I'll load this into memory. Notice this time that when it fails to find the first note process, that because we put the error action stop, it went ahead and went to the catch, and we had it throw. And throw is the term in PowerShell that halts all further action. So if you want your code to stop and not perform anything else, throw is the way to make that happen inside of PowerShell. So because we fell down into the catch, we wrote out which process we had an issue with, not a process, and then we went to throw. And because we threw, we did not repeat the loop. In PowerShell, try-catch also has a finally statement, which I'll introduce you to now. So take a look at what I have here. This is the same example as before with the try-catch trying to find that file. We have specified error action to stop, so this will terminate and fall back to the catch. And we'll write the error out to the screen so that you or the user can see it. But notice this finally. This finally is going to perform an action after the try-catch regardless if it succeeds and goes to the success pipeline, or if it errors and goes to the error pipeline, regardless of which outcome occurs in this try catch, the finally will perform the final action. So a common example of what to do here is if you try and are successful, great, then log that out to the console in the finally block. Or if you error, then go ahead and log that error out to the logging file of some kind as well. So you can put stuff in the finally that will occur after the try catch, regardless of the outcome. Now that we've got some basic information about PowerShell errors and exceptions, let's dive into some more practical examples of things that you might see in the real world. So let's load up an example where we try to visit a website. There are a variety of reasons why this might fail. You may not have a connection to the web at the moment for some reason and may not be able to hit this. The website might be down. The website might not actually exist. So there are a variety of reasons why this invoke web request might not actually succeed. So again, we're going to put this inside of a try catch and try to evaluate the results and take action depending on if this is successful or not. Again, you should always get in the habit of specifying ErrorAction and set it to stop. Okay, so this is visiting the TechThoughts.info blog, and it's visiting the nope.htm page, which I can guarantee you does not exist. So this is going to encounter an exception, and we should expect it to write that error out to the console. So I'm going to load this up, click F8, and sure enough, we get an error back. Now, depending on what version of PowerShell you're running, PowerShell 5 or PowerShell 6, PowerShell 7, you may see a very different type of error here. But the point I want to make with this particular example is that this error is not very helpful to your end user. It's basically showing that it tried to visit the page, but it wasn't found. And this type of error is pretty common for most users. Users understand visiting a web page and seeing that it's not found. And if they were doing this inside of their browser window, for example, people are used to seeing an error like this. The page you're trying to reach does not exist or has been moved. But the exception that we get written out to the error pipeline inside of PowerShell is not immediately indicating that. And so what I want to show you is that this error object that's been put out to this error pipeline is actually a very rich PowerShell object. So as we learned, PowerShell deals in objects, and its errors are rich objects as well. And we can evaluate them and their subproperties. Let's try this again, but with a little bit of logic added into our web request. Again, getting in the habit of adding ErrorAction to all of our commandlets. So again, this website does exist, but the page doesn't. That's the expectation of what we're trying to handle here. So we're going to be expecting a 404. So I'm going to load this into memory and walk you through what this is actually going to accomplish. And you'll see right after the bat that we're going to get a much more intuitive warning out to the console. So which one of these would you rather your user see? Would you rather them see this? Or would you rather them see a warning saying, "Hi, the web page was not found. Check your address and please try again." So let's walk through what I just accomplished. So we know that we failed to visit this website and we got an exception, but it's not an uncommon exception. It's I can't find the website. We're pretty used to seeing this in web scenarios. I'm going to go ahead and take that error pipeline object and load it into the variable the error. So now I have that loaded inside of that variable. Because I have that loaded inside of that variable, I can pound that out to the console down here by typing in the error, and I can see that particular rich object out to the console. Now, this has subproperties, just like all objects in PowerShell do. And so I can evaluate these. So I can, for example, format that to list. I want to see all properties and I want to force it. In PowerShell, when you're evaluating all of the subproperties of an error object, you should use the -force parameter to do so. I'm going to go ahead and click enter. Okay, so no surprises here. Lots of subproperties to work with. We see we have an exception property, what kind of category the error is, the error details, including some of the information that I got back from the page, so on and so forth. So let's go back up to the code and notice that I am exploring specifically the subproperty exception. So let's take a look at that inside of the console. So I'll type in the error dot exception. And before I even finish typing that, I'm just going to click tab And because that is a subproperty, IntelliSense took care of that for me. So notice that the exception subproperty actually contains a exception message, which is the response status code does not indicate success, 404 not found. Now, most people know what a 404 is. And so all I'm doing here is looking to see, hey, is that exception like wildcard 404? Does it contain 404 inside of the exception? And if it does, I can write a warning to the user saying, hey, that web page wasn't found. Please check your address. Now notice that I have that in an if statement, that if it does contain that 404, we're going to provide that nice friendly message to the user. But any other situation, I'm going to go ahead and throw, which is going to throw the error out to the error console so that you or the user can see it. And we're going to stop doing anything else in the code. Let's run through another example and see how that is going to differ depending on which error that we wind up with. Again, clearing out the console so we can start fresh and adding our ErrorAction to stop. So we force ourselves into the catch. And this time we're going to go to TechThoughts, which it doesn't actually exist. This domain doesn't, this is not going to be a real website. And so our exception to this particular error is going to be different than when the page does not exist. Let's explore what that's going to look like now. So I'm going to, again, attempt to visit that, and it's going to error. And notice this time that we put out no such host is known because I'm writing that to the console here. So again, I'm loading the output to the error pipeline into the error variable. And then we know based on previous lessons that this is just outputting to the console. So the error.exception this time is loaded with no such host is known. So again, a different exception in here, and you would have to handle things a little bit differently for this particular situation. Let's spend just a minute on the error variable. There is an error variable that's reserved inside of PowerShell. It's $error. And what this does is it contains all of the errors that PowerShell has encountered in this particular session. So you'll notice, because we've been generating quite a few errors as we've walked through several of these examples, that the error variable contains many of the errors that we've already generated. So this is just an array of the errors that we've encountered up to this point. And if you're writing PowerShell and have forgot to trap one or want to explore one of the errors, you can go back to those by visiting the specific error in the array. And so the first one in my error array right now is no such host is known when we encountered an issue invoking that web request. Notice that if I load in 1 divided by 0 and visit the first one in the array this time, that this time error 0 is attempted to divide by 0. So you can always go back and evaluate those rich error objects to determine exactly what's going on inside of your code. If you've generated quite a few errors and you need to clear out that particular error variable array, you can always run error.clear because that is a supported method. And if I execute that inside of the console window, now error is empty and doesn't contain any particular errors. So let's wrap up with a super practical example of something that you might actually put inside of production. So I'm going to open up a new tab with Control N. So we got a new window up here. And instead of clearing the window this time, what I'm actually going to do is I'm just going to delete it and start fresh. So you'll notice this delete button over here where I can kill the terminal and kill the integrated window. It'll ask me if I want to go ahead and restart it. I'll say yes. And that gives us a nice, clean, fresh PowerShell window with no history from the previous stuff that we had. So I'm going to load up that practical example and let's walk through this and determine what's going on. So at this point in the series, we're comfortable with read host. What's going to prompt our user to enter a URL. We're going to load that into the URI variable. Now we're going to use invoke web request to visit that particular web address. And if we encounter any errors, we're going to go ahead and stop. And that's going to force us into the catch. And in our catch, we've got quite a few pieces of information going on here. So notice that I'm going to go ahead and drill down quite a bit into the error object. So this is the error object right here, that $_ being loaded into status code value. And I'm evaluating the exception response status code value subproperties. Again, you can explore all of these subproperties of the error object Every error is going to have different subproperties, but remember, you can always pipe it out to format list-force to see all of what you have to work with. So we're loading this particular subproperty into status code value, and then we're going to put this into a switch. And depending on what error status code we get back from that website, we're going to provide our users with really informative, useful error information. So if we get a 400, we're going to say, hey, that's a bad request. Most likely you typed in the URL wrong. If we get a 401, you don't have access to that site. If you get a 403, you're forbidden. 404 is not found. And so our users are going to be set up for success here because they're going to know exactly what's going on and how to address this particular situation. So let's go ahead and load this up and click F8. And the first thing we get is enter the URL. So let's go ahead and enter a URL that we know is not going to exist. So I'll type in https www.google.com. And if I enter that, what are we going to get back? No such host is known. Now notice that I did not get a warning out to the console. I got a throw. That's because we're not accounting inside of our switch here for the status code of no host is found. So what happened here is we tried to evaluate this website using invoke web request. We exceptioned. We went down into the catch. It went into the switch after it evaluated the subproperty. It tried to find 400, 401, 403, 404, and 500. It didn't find any of those and defaulted to the last thing, which is to throw out and just stop everything and provide that unexpected error to the user. I'm going to clear the console and I'm going to load all this in with Control A. So I'm selecting everything with Control A and I'm going to F8. Again, we get that URL down here. And this time I'm going to type in techthoughts.info, which is a good domain. And then I'm going to give it the nope.htm, which I know that particular page does not exist. I'm going to click enter. And instead of getting a throw, what happened here after we evaluated that subproperty is we did find a match for the 404. And we wrote out a warning to the user telling them, hey, that particular web page doesn't exist. Check the URL and try again. So now your user could check the address that they actually entered and be like, oh, okay, that nope.htm doesn't actually exist. I'm going to change the website and instead I get a good return. I hope you found this video on how to handle PowerShell errors and exceptions informative. Remember that all of this information is available in written format on the techthoughts.info blog. If this video helped you out, go ahead and click that like button and subscribe for more Tech Thoughts videos.